Tomorrow will be better. Find the value of x for which the uniform bar below is well balanced. Two keywords here, dear friends: balanced and then uniform. Uniform implies that the weight of the bar is uniformly distributed. And then balance means that all these forces are in perfect equilibrium. Follow me, dear friends. Solution. We have to apply the law of moments here, according to which there are two aspects of this law of moment. The first one is all the forces acting on the object should be well balanced or in equilibrium. This implies that in our case, all the upward forces will have to equal all the downward forces. Let me just emphasize that there is an upward force here which I'll call R, which stands for the reaction force from these two forces which are acting on this pivot. So let's apply the first part of the law of moments. Upward forces x Newton plus R should equal downward forces 200 Newton plus 300 Newton. We can call this equation 1. Now the second part of the law of moment says if we take the moments about one particular point like this one, all the clockwise moments should equal the anti-clockwise moments. Now if we fix here to be our pivot, which force is likely to cause a clockwise moment? We have two of them. We have this one and this one. So according to the law of moments, the moment caused by this force and this force, which are, we have 200 Newton times its lever arm. Watch out for the units. 0.4 plus the second force, which is likely to cause a clockwise rotation, is x. So x times its lever arm, which is 0.2. Lever arm is just the distance, the perpendicular distance from the force, point of action of the force to the pivot. So this should equal the sum of the anti-clockwise moments. This is the only force here likely to cause an anti-clockwise rotation about this point here, the 300 Newton. So let's find its moment. It's going to be 300 Newton times its lever arm, which is not 30 cm, but rather 0.3 meters. At this point, all we have to do is to make x the only variable of this equation, the subject of the formula, by sending every other thing the other way. At the end, you're going to have that 0.2x is going to be equal to 300 times 0.3 and then minus 200 times 0.4. And if you correctly do this, you will have that x is going to boil down to 50 Newton. This is the value for x for this bar to be balanced. Tomorrow will be better.